So we know how to do LRAM, RRAM, and MRAM. What we're going to look at now is trapezoidal approximation. So if you remember when we've been doing our waves, I'll go ahead and set up this equation for us. So sine from 0 to pi, make this more visible here. Our curve's going to look like this. We've been doing rectangles, which gave us a lot of overestimation or a lot of underestimation, right? We also went in and did MRAM, still seeing some over and under. What we're going to look at now is trapezoidal, which when we build a trapezoid, so I'll build this one here, when we connect those bases or those heights, we're not losing as much area, okay? So if you remember, how do we find the area of a trapezoid? We're going to take height over 2, then we're going to multiply that to base 1 plus base 2. So this is the area of our trapezoids. So once we know that, the rest is straightforward. With this one here, because we're going to use 4 intervals and they're going to be the same depth, we can use a little bit of a shortcut here. So what happens is my first trapezoid, so its height is pi over 4, because we're going to split this into fourths, like such. That's just pi, not 2 pi, sorry. And I'm just going to multiply that by 1/2. So height over 2 is the same as multiplying by 1/2. I'm going to take the first base, which I'm going to base it off of here. Sine of 0 is 0, plus the sine of pi over 4, which is root 2 over 2. I'm going to do the same thing. I've got 1/2. The height between is pi over 4. So from pi over 4 to pi over 2. And now I'm using pi over 4 and pi over 2. Notice how we have that repeat. Okay? So then I have plus 1/2 pi over 4. Now I'm using pi over 2 and 3 pi over 4, so that's 1 plus root 2 over 2. And my last trapezoid, uniform height between our bases here, we're going to use 3 pi over 4 and pi, so that's root 2 over 2 plus 0. So that's a lot of writing, right? But because our height, our distance between our bases is uniform, so our height is the distance for our intervals, it's all the same, I could have written this as one multiplication out front, and then I had base 1, and I used this base twice. I used this base twice. I used this base twice, and my last base I used once. So that pattern is going to hold true as long as our height is uniform. So what we're going to see is our area is going to be height over 2, base 1, plus 2 base 2, plus 2 base 3, plus, and then we're going to have 2 base n minus 1, plus base n. To show here that our first base and our last base, first and last, you only use once. Everything else gets doubled. A nice little shortcut for finding the area using trapezoidal. Here, we're going to go ahead, our zeros go away. This 1/2 is going to get rid of all of those 2's. And then I have root 2 over 2 plus root 2 over 2, so there's 2 of those. And then we have that 1. So this is pi over 4 times 2 root 2 over 2 plus 1. So that is pi over 4 times the square root of 2 plus 1. It's not a pretty answer, but it's an answer all the same. Okay? So if you remember our trapezoidal rule here, height over 2, height is the distance between bases. Base 1 plus 2 base 2 plus 2 base 3, all the way till we get to the one final base n. Okay? when we're given a table, that little shortcut could be helpful when we have, again, uniform heights. But if we don't, we're just going to jump in and set this up. So if we split this like such, so we're going to have 4 trapezoids. Here my base is 3, or my height is 3, and then I have base 1 plus base 2. 5 to 8, again I have a base of 3, so height over 2, base 1 plus base 2. 8 to 10, I have a base of height of 2, and then that's negative 2 plus 1. I have to move down here. 10 to 13, that's 3 over 2, and then 1 plus 5. So there's my trapezoidal. The height, which is the distance between our x values, and then our base 1 plus base 2 are our y values. So this is 12 divided by 2 is 6. So that's 18. This is 7 times 3, which is 21 over 2. This one is negative 1. 6 divided by 2 is 3, so this is plus 9. So I've got 18 minus 1 is 17, plus 9 is 26, plus 21 halves, so I'm going to double this. 52 plus 21 over 2, we get 73 halves. Trapezoidal rule. Okay, go forth and approximate.